In today's class, we are going to discuss arithmetic progression. Here we have 6 sequence of numbers on the left side and another 3 sequence of numbers on the right hand side. Ordered list of numbers. Sequence means ordered list of numbers. So here on the right hand side, we have 1, 4, 6, 11, 10, 11 and 17. Now the difference between any two consecutive terms of this sequence is how much it is? 1 and 4, it is 3. What is the difference between 4 and 6? It is 2. And 6 and 11, it is 5. Between 11 and 17, we have 6. Here, the difference between this number and this number, it is 2. And this number and this number, it is 4. And between 18 and 16, 8. Again, here we have difference between minus 6 and minus 5 is plus 1. Then minus 5 and minus 3, it is 3. And minus 2 and 7, it is 9. And 7 and 16, it is 6. Okay. Now, on the left hand side, we have difference between 2 and 5 is 3. Between 5 and 8 is also 3. Between 8 and 11 is also 3. Here, difference between minus 6 and minus 6 is 3. Between minus 3 and 0 is also 3. Between this and this is also same, and between this and this is also same. Here, the difference between this one and this one is 0. Again, this one and this one is also 0, and this one is and this one and this one is also 0. Three by 2, 5 by 4, 1, 3 by 4, half. What is the difference between these two? 3 by 2, 5 by 4 is minus 1 by 4. Difference between these two is minus 1 by 4, because 3 by 2 minus 1 by 4 is 4, 6 minus 1, 5 by 4. Hence, the difference between this and this one is minus 1 by 4. Again, this one and this one, the difference is minus 1 by 4. Here also it is minus 1 by 4, and here also it is minus 1 by 4. Similarly, here also the difference is 0.5. Between this and between this also it is same. And here also the difference is 1, plus 1. So you can see, on the right hand side, we have sequence of numbers where the difference between any two consecutive sides is different. And on the left hand side, we have sequence of numbers where the difference between any two consecutive numbers is constant. It does not change. This type of sequences where the difference between any two consecutive numbers is same or constant, it is called an arithmetic progression. So what is an arithmetic progression? It is a sequence of numbers, where difference of consecutive terms is constant. It does not change. Okay? So, such sequences are called arithmetic progression. And sequences where the difference is different, then those sequences are not arithmetic progression, and differences where the difference is constant, common difference, this is also called a common difference. It is constant, it is called an arithmetic progression. So an arithmetic progression is a sequence of numbers where the difference between any two consecutive terms in the progression in the sequence is constant. That is an arithmetic progression. As you must have noticed that these sequences are all real number sequences. So an arithmetic progression can have square root, decimal, fraction, they can be all equal, negative and positive and all negative. It does not matter. And also the common difference between any two consecutive terms can be positive or negative. For example, most of the sequences had a positive common difference. For example, this one, the difference between 5 and 2 is 3, plus 3. Again, between 8 and 5 is plus 3, between 8 and 11 is plus 3. So it is a positive common difference, but it can be a negative common difference also. For example, if we write this sequence like this, then the difference is minus 3. Okay, so the common difference can be positive or common difference can be negative, like this. It does not matter. Let us take this sequence of this arithmetic progression, because it is an arithmetic progression with common difference 3. So this is the first term, this is the second term, this is the third term, this is the fourth term, right? So what will be the fifth term of this arithmetic progression? If there is a fifth term, then what will be the fifth term? Why? Because the difference between these two is 3, which is the common difference of this arithmetic progression. So it will be 14. And what will be the next one? It will be 17, 6, and so on. Now, suppose this arithmetic progression has 20 terms, not 6 terms like this, but there are 20 terms in this arithmetic progression. And you have to find the last term, the 20th term. What will be the 20th term of this arithmetic progression? That is what you are required to find out. So what you will do? Let me write it like this, it will be easier. Two, 5, 8, 11, 14, 17. This is first, second, third, fourth, fifth, sixth. So we need the 20th or the last term. Okay, we don't know what it is, we don't know. So there is a way to find the 20th term. We'll go on writing like this, 17, then plus 3, then plus 3, then plus 3, and plus 3 up to 20th. But is that practical? That is not a practical solution. So what is the way to get it? What is the way to get the 20th term of this arithmetic progression? Let us see. This arithmetic progression, if you notice carefully, the first term is, suppose the first term is denoted by A, which is 2. Okay. The next term is obtained by 2 plus 2 minus 1. What is the common difference? Common difference is 2 again. Sorry, 3. Okay. So how much you get? This is the second term is obtained by adding the first term with 2 minus 1 into 3, which is 5. We get the second term, value of the second term. How do we get the third term? Again, the first term plus 3 minus 1 into the common difference. How much we get? 6 plus 8, 6 plus 2, 8. We get the third term. What is the fourth term? 2. 4 minus 1 into 3, 11. Do you see a pattern here? Fifth term. The fifth term is obtained by subtracting 1 from 5, then multiplying by the common difference, then adding the first term. We get the fifth term, right? So it is obvious what will be the sixth term, seventh term, eighth term, ninth term, etc. So how we are getting the terms each term? Suppose you are asked to find the fourth term. We are getting the fourth term by adding the first term to 4 minus 1 into the common difference, right? In every case, to find any term, what we are doing, suppose third term, we are doing the first term into 3 minus 1, the position of third term, minus 1 into the common difference. Add it together, you get the term, right? So, following this, what do we get the formula? How we get the nth term or the last term, 20th term? The 20th term obviously will be 20 minus 1 and the common difference, right? So what it will be? 2, 20 minus 1 is 19, 19 into 5, 3 is 57, 58, 59, 59. It will be 59. If you go on adding plus 3, plus 3, plus 3, plus 3, you will see that the 20th term is 59 indeed. Okay? So, this is the formula for getting any term in the any term of the arithmetic progression. So to find the nth term of an arithmetic progression, the formula is, we write the nth term as an. Okay? The formula is a plus n minus 1 into d. What is d? D is the common difference. And what is a? A is the first term. So if a is the first term and d is the common difference of an arithmetic progression, then the nth term can be obtained by adding the first term n minus 1 into the common into common difference. What is n? Position of that term inside the arithmetic progression. Here we are told to find the 20th term, so we write 20 minus 1 into 3 plus 1. The first term into n minus 1 into d is 59, the 20th term. Okay? We write the formula again. A plus n minus 1 into d, where a is first term and D is common difference. So if you know the first term of the AP and the common difference, then we can get the nth term with this formula. An is equal to A plus n minus 1 into D. The first term into n minus 1 into common difference, where n is the position of that particular term. You want the third term, you write A3, then A plus 3 minus 1 into D, and like that. You can find any term, the value of any term of this arithmetic progression using this formula. Okay, you have to remember this formula. First term plus position of the term that you want to find out minus 1 into common difference. This can be applied to any arithmetic progression. Let us take an example. This is an arithmetic progression. What is the common difference? The first term. Let us take the first term first. First term, which is A, is 1. What is the common difference? Common difference is denoted by D. So what is the common difference between two consecutive terms? It is 4. So we have the first term and the last term, and we have the formula to find any term of this arithmetic progression. So there are 4 terms here. What is the, suppose you are required to find the 6th term, okay? 6th term, it is not known. So what will be the value of 6th term? It will be S6. Then what is A? It is 1. What is N? N is 6. So 6 minus 1. What is D? It is 4. And what is the value now? 6 minus 1, 4, 20 is 21. Okay. So let us verify if it is really 21 or not. What is the value after 13? The 5th term. It will be the 5th term. It is 17, because you have to add 4 so that the common difference remains constant, 4. So 5th term is 17. What is the 6th term? The term that we want to find out. It is 21 plus 4. You get 21 here. So it is verified, right? So we have proved that to find any term of this arithmetic progression, we can apply this formula and get that particular term. And as I said earlier, it is applicable for all arithmetic progression. If you know the first term and the common difference, you can find the nth term of the arithmetic progression with this formula. By the way, one more important thing to remember is that most of the students get confused here. I have noticed that n denotes the number of the position of the term. It is not the actual value of the term. For example, in this arithmetic progression, there are 6 terms, total 6 terms. This is first term, this is second term, this is third term, and so on. So, if you are told to find the 4th term, it denotes the position of the term. Position is different and value is different. So n is position, not the value. Okay. Another important thing to note here is that the terms, let us take this arithmetic progression. Here the first term is 2, next term is 5, next term is 8, next term is 11, and so on. The first term can be written as A is the first term. The next term can be written as AD. The next term can be written as A plus 2D. Next term as 3D, and so on. Do you follow this? Let me verify. 2 is A already, this first term. What is 5? A plus D. What is A? 2. What is D? 3. So we get 5, right? What is the third term? A is 2. What is 2 into common difference 3? It is 6 plus 2, 8. Again this one is 2. 3 into 3, 9, 11. So we get the terms like this also. So the arithmetic progression, if you know the first term and the last term, the arithmetic progression can be written like this also. Actually this follows from this formula. Okay, first term, second term, third term, fourth term, the consecutive terms of the arithmetic progression can be written like this also, if you know the first term and the common difference, right? So let us stop for today.